Okay guys, this is FRQ 355, particle motion again. And let's look at this question. It's kind of interesting. First of all, you start with two particles. It goes from 0 to 8 for both of them. Well, it really doesn't say 0 to 8 for Q, but anyway, the position function is given by xp of t. So this is the position function of x and the velocity function of q. So we have two different, we have a position and a velocity. Particle q, they give you, this would be that x of 0, xq of 0 is equal to 5. All right, so it's set up with two particles. One is giving you position and the other one is giving you velocity. So you just have to take that all into consideration. So part A says for 0 to 8, when is particle P moving to the left? So for A, particle P moves to the left when v of t is less than 0, right? When the velocity is less than 0. So we do not have particle P in terms of velocity, so we have to take the derivative of the position function. So we're going to say that v particle P at t is equal to the derivative of the position function of particle P at t, which if you take the derivative of particle P, the ln function, it's 1 over t squared minus 2t plus 10 times the baby, which would be 2t minus 2. Chain rule there. So you get 2t minus 2 over t squared minus 2t plus 10. And we want to know when that's equal to 0 first, because then we can do a little sign chart. So we got 2t minus 2 equals 0. So factor out a 2 and you get t minus 1. So you have a critical point at 1, and it was from 0 to 8. Okay, so you can't use end behavior for this rational function. So you're going to have to test points. So let's try a half back into this. Okay, and all I care about is the positive and the negative. So if I put a half in there, that will give 1 minus 2. So on the top it would be negative. If I put a half in the bottom, it would still give me, a positive. So between 0 and 1, I have a negative, because a negative over a positive is negative. Then if I put like 2 in, I get 4 minus 2, which is positive on the top, and then I would get a positive on the bottom. So that's going to be positive between 1 and 8. So the question asks, when is it moving to the left? Left was less than 0, so we would say that particle P is moving to the left. And then when is it negative? From 0 t to 1, because velocity is negative during this interval. Okay, so there is part A. Let's get our points. It's worth 2 points total, and you get a point for the derivative. So you get a point for taking the derivative, and you get a point for the answer 0 to 1 with the correct reason. All right, so that's part A. Let's move to part B. Okay, part B says, hey, between 0 and 8, find all the times where the two particles travel in the same direction. So I just have to get the second particle and find out when that is positive and negative, and then do maybe a double sign chart. All right, so let's start with B here. We would say VQ of t is equal to t squared minus 8t plus 15. and we set that equal to 0. And we factor out to t minus 5 and t minus 3 equals to 0, so equals 0. So we have a 3 and a 5 on this sign chart. Goes to 8 and starts at 0. So now this one we can use end behavior. So our graph would come down and go up. So this would be positive between 0 and 3, negative from 3 to 5, and positive from 5 to 8. So that's using end behavior. So now let's do a double sign chart. From part A, we knew that it had a critical point at 1. So we're going to have 0 and then 1, and then the 2 from this one, 3 and 5 and 8. And I'm going to do P first and then Q. So P was was negative till 1, so negative, and then it was positive all the way to 8. And Q, if you look at this is Q, it is positive between 0 and 3, so that would be a positive here and a positive here. And then it was negative between 3 and 5, and then positive again after 5. So if we identify where they wants to know when they're in the same direction, so that means they would both be traveling to the left or right. So right here, they're both traveling to the right, and again here, they're both traveling to the right. So the answer would be particle P and Q are traveling in the same direction from 1 to 3, and again from 5 to 8. Okay, and it doesn't say explain it, so I think you're going to be good with that. So let's calculate your points. Here we go, points. You get 2 points for part B. You get 1 point for getting the intervals right. And you get 1 point for the analysis. So this is interesting. It's not supposed to accept sign charts as analysis, so I probably wouldn't get that point. And you notice it didn't say to do the analysis, but then they're giving you a point for that. So you shouldn't do what I just did. You shouldn't just say, hey, they didn't ask for it. Do it anyway. So because I'm going to add this, I would have lost that point because P and Q both have the same signs. The velocity, we should say velocity. P and Q both have the same signs during those intervals. Okay, so there's your other point if you had analyzed it. Okay, so that's part B. I'm going to stop and do a second video for C and D.